Okay, hello everybody. So today we're going to be moving on to our last chapter for probability. So this is probability combined with two-way tables and tree diagrams, okay? So you might remember a good few months ago now we were looking at two-way tables and tree diagrams. So we're going to come back to those and we're going to use these to calculate probabilities. So our learning intention for today is I will be able to create a sample space and calculate the probability of an event occurring from this space. And if you remember, our examples of sample spaces were two-way tables, tree diagrams, and also systematic listing. But today we're just going to look at two-way tables and tree diagrams. Probability combined with two-way tables and tree diagrams. So before we start, just like we usually do in our lessons, I've got 3 questions here. So I'd like you just to pause the video, maybe take a screenshot and answer those 3 questions. So it says a card is selected at random from a standard pack of 52 playing cards. Find the probability that the card selected is A, a black card, B, a diamond, or C, a queen. And as a little hint, just think about in your deck of cards, how many black cards are there? How many diamonds are there? How many queens are there? And that should help you. And when you're finished that, I want you to make sure that you upload that onto Seesaw along with the other work you'll be doing for today's class. Okay, so before we start doing some questions, I want us to have a look at 2 definitions. So the first definition is successive events. And successive events are 2 or more events occurring in succession or a sequence. So an example of a successive event is, just say you flipped a coin twice and it landed on tails both times. This would be a successive event, okay? Similarly, if you flipped the coin twice and it landed on heads both times, that would also be a successive event, okay? It happened in succession. First it landed on tails, then it landed on tails again. Or the other way, first it landed on heads, and then it landed on heads again. Now the other definition we're going to look at is independent events. And these are events in which the probability that one event occurs has no effect on the probability of the other event occurring. Okay, so an example of an independent event is, just say you roll a dice twice, and the first time you roll a 6, this will have no effect on what number you're going to roll the second time. Okay, just because you rolled a 6 the first time doesn't mean there's any less chance you're going to roll a 6 the second time, or there's a bigger chance you're going to roll a 3 this time. Doesn't matter, okay? So whatever number you roll the first time has no impact on the number you're going to roll the second time. And that's an example of an independent event. So I'd like you to take down, I'm going to put little stars so you just know, this little definition and the example, this definition and the example into your copy, okay? So you can just pause the video and write those down into your copy. And your heading is going to be probability combined with two-way tables and tree diagrams. Okay, so we're going to have a look at a question that combines probability, this time with a tree diagram. So it says here, a fair coin is flipped twice, and part A says, copy and complete the following tree diagram to show all the possible outcomes. So this is just filling out our tree diagram like we did before. So when we flip a coin, for example for the first flip here, the options are going to be a head or a tail. Okay, so they fill them out for us. Now for the second flip, just say they flip head on the first flip. For the second flip, they're either going to flip a head or a tail. And similarly, if they flipped a tail for the first flip, for the second flip, they're either going to flip a head or a tail. Okay, so now we have all our second flip outcomes done. So we need to just combine our outcomes. So you might remember this, you follow the branches on the tree. So if they flipped a head the first flip and they flipped a head the second flip, their outcome is head, head. If they flipped a head on the first flip and a tail on the second flip, the outcome would be head, tail. If they flipped a tail on the first flip and a head on the second flip, this outcome would be tail, head. And if they flipped a tail on the first flip and a tail on the second flip, that outcome would be tail, tail. Okay? So we filled out our tree diagram there, and hopefully this is bringing back memories for you of how to fill out a tree diagram. So now we're going to answer our questions. So first question there, part B asks, how many outcomes are there? So I have head, 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 tail, tail, head, and tail, tail. So that first question is going to be 4 is my answer. Okay, how many outcomes have a head on the first flip and a tail on the second flip? So, head on the first flip, tail on the second flip? No. Head on the first flip, tail on the second flip? Yeah, so I'll just mark that. Head on the first flip, tail on the second flip? No. Head on the first flip, tail on the second flip? No. So I only have 1. So answer there is going to be 1. What is the probability of getting a head on the first flip and a tail on the second flip? So it only happens once, we figured out. And we know there's 4 outcomes. So the probability of getting a head on the first flip and a tail on the second flip is going to be 1 in 4, okay? Because it happens once and there's 4 outcomes. We could also say 0.25 there. Then they ask, is this the same outcome as a tail on the first flip and a head on the second flip? So they're basically saying, are they the same thing? And we know they're not the same thing, because the first time in question D, we said that it landed on a head first and then a tail. Then in question E, it lands on a tail first and then a head. So just because we have a head and a tail both times, because they're in different orders, they are different outcomes. So no, it is not the same outcome, because one of them had a head first, then a tail. The other one had a tail first and then a head. Then the last question is, what is the probability of getting the same outcome on both flips of the coin? So that's if I got a head, head, or a tail, tail. So head, head happens once, tail, tail happens once. Okay, so probability of getting the same outcome on both flips of the coin. So, as I said, head, head happened once, tail, tail happened once. So the number of times I got the same outcome was twice, because I could get a head, head, or I could get a tail, tail. Okay, so it happens twice. My number of outcomes is 4. And I can simplify that to 1 over 2. Or I could also say 0.5. Okay, so just to recap on that, we saw that we got the same outcomes on both flips when we got a head, head, or a tail, tail. That happens twice, and we have 4 outcomes altogether. So 2 over 4, which breaks down to 1 over 2, or 0.5. Okay, I'm going to have a look at another question here. So this is revisiting our two-way table. So it says here, a die is rolled and a coin is tossed. Draw a two-way table of the possible outcomes. Okay, so let's have a look here. My outcomes for my die are already written up there. They say 1, 2, 3, 4, 5, 6. Now I need to write out the outcomes for my coin. So what are the outcomes for tossing a coin? I can get a head or a tail. Okay, so let's fill out my table now. I'm just going to draw my boxes to make it a little bit clearer. Down, down, and another one here. Okay, so my first box, H1, I'm going to write there. Next box, I have a H in this line, 2 in the column, so I get H2, H3, H4, H5, H6. Now down here, my line is tail, my column is 1. So I have tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. Okay, so I'm going to answer the question now up the top. And this question said, find the probability of getting a head and an odd number. Okay, so I need to find out how many times that happens. So I'm just going to mark them with a little green spot. So head and odd number. So H1, is that a head and odd number? It is. Head 2, 2 an odd number? No. Head 3, yeah. Head 4, no. Head 5, yes. Head 6, no. Tail 1, no, no head. Tail 2, tail 3, tail 4, tail 5, tail 6, no, because they don't have heads. So, I have 3 options where there's a head and an odd number. Now, how many outcomes do I have altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So the probability, just draw an arrow down here, of getting a head and an odd number is 3, because it happens 3 times, over 12, the total number of outcomes. And that can be simplified to 1 over 4, which is the same as 0.25. Okay, now we're going to answer the second question, which says, find the probability of getting a tail and 4 or a tail and 5. So once again, I have to figure out how many times does that happen. So I'm going to mark them with yellow. Head 1, no. Head 2, no. Head 3, no. Head 4, no. Head 5, no. Head 6, no. Tail 1, no. Tail 2, no. Tail 3, no. Tail 4, yeah. Tail 5, yeah. Tail 6, no. So tail 4 or tail 5 happens twice. And I know I have 12 outcomes. So it happens twice over the number of outcomes, which is 12, which simplifies to 1 over 6. And that's the answer for that question there. Okay, so if you could please take down this example into your copy. Okay, so just briefly write out the question and write out the solution there as well. That would be really, really good, and you can use this then to look back on. Okay, so we're going to look at one more example, okay? And this is our menu, and we would have looked at these menu questions before when we did tree diagrams for the first time. So, a chef designs the following menu. For starters, there's potato soup or garlic bread, and for mains, there's beef, chicken, or vegetarian quiche. And part A says, draw a tree diagram to show all the possible menu choices. Okay, so let's draw that here. So, we start off with our branches, and we're going to say this is our starter, okay? So our starter options are potato soup, so I'm just going to write PS, garlic bread, GB. I'm going to make this a little bit smaller. Okay, now I have my main. So how many options do I have for main? Beef, chicken, and vegetarian quiche. So 3. I'm going to write main up here. And also, for garlic bread as well, if they chose garlic bread, they'd also have the option of choosing beef, chicken, or vegetarian quiche. Okay, so all we've done is to recap there. We have drawn our 2 branches for our starters, because there was 2 options for starters, potato soup or garlic bread. Then we said, if they chose potato soup, they would be able to choose beef, chicken, or vegetarian quiche. Then if they chose garlic bread, they'd also be able to choose for their main beef, chicken, or vegetarian quiche. So now we're just going to write all those outcomes down. So we follow our branches. So let's say they got potato soup and they got beef. That outcome will be, PSB. Then if they got potato soup and chicken, we'd have PSC. If they had potato soup, vegetarian quiche, we'd get PSVQ. Let's say they had garlic bread and beef, we'd have GB and B. If they had garlic bread and chicken, we'd have GBC. And if they had garlic bread and vegetarian quiche, we'd have GBBQ. So they're all my outcomes there. So now we go to part B. So it says, a food critic enters the restaurant and decides to pick at random from the menu. Find the probability the critic picks soup for the starter and beef for the main course. So how many times does that happen? So, soup for starter, beef for main course. Yep, happens here. So let's draw a little red dot there. Soup, beef, no. Soup, beef, no. Soup and beef, no. Soup and beef, no. Soup and beef, no. Okay, so it happens once. And how many outcomes are there in total? There are 6. So the answer is 1 out of 6. Then the next question is garlic bread for the starter and a meat dish for the main course. Okay, so we need to find out how many times that happens. So potato soup, no. Potato soup and chicken, no. Potato soup, vegetarian quiche, no. We need garlic bread. Garlic bread and beef, yes. Let's put a little black dot there. Garlic bread and chicken, yes. Garlic bread and vegetarian quiche, it's not a meat dish. So the number of outcomes that have garlic bread for the starter and a meat dish for the main course is 2. Garlic bread and beef and garlic bread and chicken, okay? And we know the total number of outcomes is 6. So probability is going to be 2 over 6, which simplifies to 1 over 3, okay? And really like if you could take down this example in your copy, okay? So you write out just a little part of the question and then write out the solution there into your copy. Okay, so when you've finished all those questions, I'd like you to try question 5, 6 and 7 on page 142 and 143 in your books. And when you do those questions, if you could please post your solutions to Seesaw, that'd be brilliant.